Hey everybody, today is December the 11th. We are at Friday. Woo-hoo, we're happy about that. We're still talking about the distributive property to make it easier for us to find factors to multiply, factors that we already know like 2's, 5's, 1's, 10's, something easier for us. We're breaking those numbers up. So today we are going to become ninjas. We're going to be using the distributive property of multiplication to use our ninja skills and make it easier for us to multiply. So we're going to use a little bit of that Kung Fu Panda music and we're going to jump right into distributive property. So what does distributive mean? When I would be in class with you, I would talk about how we would distribute my papers out to you. When I'm handing those out to you, I'm distributing them to the kids in the class. So distributive comes from the word distribute. To distribute means to divvy up, spread out, arrange, hand out like I would your papers, or allocate. Think of something you could distribute. Here might be a few things. Maybe work, if you have to share the work at home with your siblings, or time. Maybe you need to spend some time with your friends, but you also want to spend some time with family. Could be land, food, kindness is a good one, water, or even helping people. So you might have to divvy those up. Here is another way to think about the idea of distributive property. And we're going to be thinking about that using that distributing thought in our mind. So I want you to think about how if I had more to move 100 pounds of rock from one part of my land to another. I know I couldn't move all of them at once. Instead, I decided to move 70 pounds on one day and 30 on the next day. Even though I didn't move all the rocks at once, eventually I did move the entire 100 pounds of rocks. In other words, I distributed my work over 2 days. You might say I divvied up or apportioned my work to make it easier for me. That's what distributive property is going to allow us to do in math. So I have 100 pounds. I did 70 on the first day and 30 on the second day. So now, in the end, I'm still moving all of the rocks, just not at the same time. So how could we apply that to math? We're going to meet the ninjas now, and the distributive ninjas will help us learn about the distributive property of multiplication. So let's meet all these guys now. So they're teamed up to help you distribute, and they're going to distribute the work between themselves. So let's solve this problem. There are 8 apple trees in an orchard. Each apple tree has 6 juicy apples ready to be picked. How many apples will be picked all together? Now, how many trees do you see? Yes, there's 8. How many apples are on each tree? So we can go and just count the apples on the tree. And if my eyes don't deceive me, there are 6 apples. Now, we want the distributive ninja to help us. We may not know our multiplication facts for 8. So let's go ahead and write a multiplication sentence that would work here. And we're going to go ahead and draw an array as well. So now that we see our array shows 8 trees with 6 apples on each tree. And our array shows 8 rows with 6 in each row. So we have 8 rows and 6 columns. Let's write our sentence. So we're going to have 8 times 6. Now, we may not know that fact. So we want to come up with a plan to help us distribute the work. So we have 8 times 6. We're going to split up the array in half so that it's a way that we could multiply easier. So we're going to split that work up. And now we have an array, two arrays. One of them is 8 times 3, and the other is also 8 times 3. Now we could also think about 3 times 8. Whatever's easier, because we can use that commutative property to help us solve this as well if we switch the order of the numbers. So 8 times 3 equals 24. The other array is also 8 times 3, which is also 24. What should I do with these products? Now remember, we have to do something with them to put them back together. That's right, we're going to add the two products together to get our final answer. So 24 plus 24 equals 48. 48. So then 8 times 6 equals 48. So we just broke this array up just to make it easier for us to use multiplication. It could look like this. So we broke up the 6. The 8 stayed the same on both sides. We broke the 6 up into 3 and 3, and we know that 3 plus 3 is 6. So we broke it up in half. We split it right down the middle to make this easier for us to multiply. So we know that 8 times 3 equals 24, and we know that 8 times 3 equals 24. We're going to add those together to get 48. Now we're going to look at this array, and we're going to see if there's a different way that we can split it up. Remember, I said we don't all look at things the same way. So this array, we're splitting that 6 up into 5 and 1. 5 and 1. So what is 8 times 5? Or we could use 5 times 8. Now this is one where we can count on our fingers. We like counting by fives. We know that 8 times 5 is 40. And the other array is 8 times 1. We know because of the identity property that anything times 1 is itself, so 8 times 1 equals 8. What should we do with those two products? You're exactly right. We should add those products together to get our answer, and our answer is going to be 48. So remember that everybody doesn't have to split it up the same way. We all look at math differently, so we could change it up. We could actually split up 8 if we wanted to. So think about what makes it easier for you using the distributive property. So then 8 times 6 equals 48. And here's what our sentence would look like. The 8 didn't change on either side, but the 6 did. It changed into 5 and 1. We divvied that up. We split that up to make it easier. And then we put our answers back together, our products back together to get our final product for the whole original 8 times 6. So let's look at another problem. There are 7 branches on a bush. Each branch has 6 ladybugs enjoying a spring day. How many ladybugs are there altogether? Now, let me tell you, Ms. Bays would not be happy here because I am highly allergic to ladybugs. They make my face swell up, so I wouldn't be happy at this place. A spring day for me would not be enjoyable because I would be inside crying because my eyes are all swollen. So in the message box on the lesson work, tell me that I am allergic to ladybugs. But I think they're so cute. So let's talk about how many branches there are. So we know that there's 7 branches based on the word problem. And we can also go over there and count them. How many are on each branch? Now we just said in the word problem it told us 6. So we know there's 6, and we could easily go count those to see that there's 6. The distributive ninjas say that that's a lot of ladybugs to count, and they can make an array to help them multiply the total. So we absolutely can make an array to make it easier for us to see it. So here is the array that shows 7 branches with 6 ladybugs on each. So in an array, we can say we have 7 rows of 6. Let's write a multiplication sentence to match the array. So we've got 7 times 6, but 7s tend to be a little harder for us to memorize. So how could we find that fact without having to memorize that? just yet. We're going to be memorizing them, but not yet. So we're going to look at our array. We're going to split it in half. And now we have an array that is 7 times 3 and 7 times 3. What is 7 times 3? You could also use 3 times 7 to help you. 7 times 3 equals 21. The other array is also 21 because it's 7 times 3. What should I do with the products? You're right. We should add those products to get 42. Now, if we're looking at this, then we know that 7 times 6 equals 42 because we broke it apart and then put it back together to get our total. So here was what our sentence would look like. Remember, we broke up the 6, so we kept our 7 the same on both sides of the plus sign, and then we broke up the 6 into 3 and 3. Now remember, we have to have parentheses around these because we have to solve these two things before we could add them together. Remember, the addition part came last after we did our 2 multiplication sentences and found our product. And here we are adding those together to get 42. There's also other ways that we could break this up. And we're going to write a multiplication sentence under each array. And we're going to solve for the problem. And then we're going to add 2 sums. Now, what I'm going to have you to do today in math class is you're going to complete a problem, 2 problems. 2 of them actually give you an array to solve. And then 1 asks you to create a multiplication sentence and an array to match, showing me where you would split it up and write 2 new multiplication sentences and put them back together, put those products back together to get the final answer. So you get the choice of what multiplication fact you use. Now, I'm already going to tell you there's some rules there. You are not allowed to use times 0 or times 1 as your multiplication sentence that you come up with, because I want you to have an array that you can break apart. If we're multiplying times 1, we don't really have anything to break apart. So what I want you to do is I want you to make sure that you use a multiplication fact that would allow you to draw a decent size array to break apart in your problem. So we're going to look at one more way that this problem could be broken up, and this time we're going to talk about how it can be broken up in a different way. So we're going to take that sentence, and this time we're going to separate 7. And we're going to separate 7 into 2 smaller factors, which is 4 and 3. And now our sentence is going to look something like this. So we need to place down in those open spaces 4, and then we're going to place 3 in the second one. We're going to get our products and we're going to add those together, and we also still get 42. So again, you see that it doesn't matter which number you decide to separate to make it easier. You're still going to get the same answer. Now, see, for me, I see that 7 as 5 and 2 because I love to multiply by 5s and 2s. But again, it doesn't matter as long as you're breaking it up and still using the same amount when you put them back together. So 4 plus 3 equals 7. It's still going to give you that same answer. All right, so again, that's all we have for today. You are going to complete the assignment. It's Google Slides. There's 3 on there. There's 2 that's already pre-made that you're going to just complete what's on there. And then the third one, you're going to come up with your own multiplication sentence. Again, you can use the manipulatives if you need to, but I don't think you're going to need to on those slides. If you didn't get finished with the iExcel that I assigned yesterday because of the technical problems with iExcel, you can do that as well and get that completed for today so I can give you credit for it. And again, remember to make a comment that you've watched my video and let me know what I'm allergic to. And we're going to end with our kung fu fighting.